Most RV owners pay the shop bill without ever knowing what happened behind the service bay doors. But experienced technicians know shortcuts and tricks that can turn expensive repairs into quick fixes, and some never appear on the invoice. Today, we're revealing 15 real RV mechanic secrets, the kind of knowledge that comes from years in the trade rather than simply following a manual. Let's start with number 15. Secret number 15, the sail switch tap test on a bulky furnace. When an RV furnace clicks, tries to light, and then shuts itself off before the flame ever catches, most owners assume the igniter is dead and start shopping for a replacement board. Here's what a tech checks first instead. Inside the furnace housing sits a small metal flap called the sail switch. Its job is to confirm the combustion blower is actually moving air before the gas valve is allowed to open. Dust, spiderwebs, and mouse nesting material collect on that flap over a single off-season and make it stick just enough to delay the signal by a fraction of a second, which the control board reads as a failure and locks out. The trick is a light tap on the furnace housing right near the blower motor while it's cycling. If the furnace suddenly fires after the tap, you've found your problem, and the fix costs nothing but a can of compressed air and a soft brush on that flap. Techs know this because sail switch failures outnumber igniter failures by a wide margin on furnaces sitting unused for more than a season. Yet the igniter gets blamed first almost every time because it's the more expensive, more obvious looking part. Here's something else worth knowing. Secret number 14, checking a roof air conditioner's start capacitor before condemning the compressor. A roof air conditioner that hums, struggles, and then trips its breaker looks exactly like a dying compressor from the driver's seat. But that hum is the compressor trying to start without enough of a jolt to get moving, and the part responsible for that jolt is a small cylindrical start capacitor sitting near the compressor terminals. A weak capacitor still holds partial charge, which is why a basic continuity test with a cheap multimeter often shows nothing wrong. What a mechanic actually does is test capacitance directly with a meter that has a capacitance setting, comparing the reading against the microfarad rating stamped on the capacitor's own label. A capacitor reading 20% or more below its rated value gets replaced, full stop, even if it still technically holds a charge. That single $15 part swap resolves what looks and sounds exactly like a compressor on its way out, and it's the difference between a 15-minute fix and a full unit replacement that a shop unfamiliar with this test will happily quote you. The next trick lives somewhere every RV has, but almost nobody ever opens, which makes the next example even more interesting. Secret number 13, the demand pump check valve chatter fix. If your water pump cycles on and off rapidly while a faucet is fully open, most people assume the pump itself is failing. In a lot of cases, the pump is fine, and the actual culprit is a worn check valve inside the pump head that's letting pressure bleed backward between pulses, so the pressure switch thinks the line dropped and re-triggers the motor. The giveaway is a rapid stutter or chatter specifically when water is flowing steadily, not when the tap first opens. Most demand pumps have a rebuild kit available with exactly this valve included, and swapping it takes about 20 minutes with the pump still mounted in place. Replacing the entire pump when it's really a $9 valve is one of the more common unnecessary part sales in this industry, and it happens because most owners never open the pump head to look. The same trend appears again. Secret number 12, burnishing new brake shoes before they ever see a hill. Electric trailer brakes that grab unevenly or feel weak right after new shoes are installed aren't broken, they're glazed. Fresh brake material has a slick factory coating that needs to be worn in against the drum surface before it develops real friction. A mechanic who knows this will drive the rig at low speed, around 15 to 20 miles an hour, and apply moderate, steady braking pressure repeatedly for about a mile, letting the shoes heat up and cool down several times in that stretch, rather than doing one long drag. That heat cycling burns off the glaze and seats the shoe material to match the exact curve of your drum. Skip this step and you'll fight uneven, grabby, or weak-feeling brakes for weeks. And a lot of owners end up right back at the shop convinced the installation was done wrong when the shoes just never got broken in. Now here's a trick that has nothing to do with brakes or motors and everything to do with how your entire rig sits on the road. Another example reinforces the same idea. Secret number 11. Checking equalizer bushings on a tandem axle trailer. Between the two axles on most tandem setups sits an equalizer bar, and inside that bar are rubber bushings that let the axles articulate independently over bumps. When those bushings wear out, you won't get a warning light or an obvious noise at first. What you'll notice instead is uneven tire wear between the front and rear axle on the same side, and a slight side-to-side sway that wasn't there before. The test a mechanic uses is simple. With the trailer jacked and the tires off the ground, grab the equalizer bar itself and try to rock it side to side by hand. Any noticeable play, more than what feels like a tight snug fit, means the bushings have worn through their rubber and metal is contacting metal. Left alone, this accelerates tire wear dramatically and eventually leads to spring hanger damage, which is a far more expensive repair than the $20 bushing kit that prevents it. Here's another clue. Secret number 10. The water heater bypass valve position that ruins your first shower of the season. This one causes more spring startup complaints than almost anything else, and it's rarely the water heater's fault. Most RVs have a 3-valve or 6-valve bypass system that lets you route antifreeze around the water heater tank during winterization instead of filling 6 gallons of tank with pink antifreeze. The trick isn't knowing the bypass exists. Most owners know that much. The trick is, the order you switch those valves back in the spring. If you open the water heater's own drain and inlet before you fully close the bypass valve, you create a dead leg pocket where antifreeze gets trapped behind the bypass valve itself and never flushes out, no matter how many times you run fresh water through the system afterward. A mechanic flips the bypass valve to normal operating position first, completely closed, before touching anything else, then flushes with the water heater bypassed from the fresh tank for a full 2 minutes before ever letting water into the tank itself. Skip that sequence, and you'll be tasting antifreeze in your coffee water for weeks. We're halfway through, and if any of these tips has already saved you a shop visit or even helped you catch a problem before it became expensive, this is a good moment to hit that like button. It tells the channel that this kind of practical, technical content is worth making more of, rather than filling the video with the same generic RV advice you can find everywhere else. And if you want the deeper version of this material, the RV Field Archive goes well beyond what we can fit into a single video. It includes 3 parts covering exactly this kind of insider technical information, with more detailed maintenance procedures, failure points, and ownership lessons that don't always make it into the main countdown. The link is in the description below if you want to go deeper and have that information available the next time you're standing in front of a problem on your own rig. Alright, enough of the interruption. Let's get back to the countdown. And that's where things become clearer.
Before we continue, there's a reason most of this is knowledge and RV service desk bills at $150 an hour. The complete RV Field Archive goes where this channel can't. The full playbook, uncut. The habits that keep a rig rolling for decades, and the thousands they save you. The code on your screen gets you in. Scan it, and let's get back to the rig.
Secret number 9. Reading a slide-out's amperage draw instead of guessing at the mechanism. When a slide-out moves slowly, jerks, or stalls part way, most owners jump straight to blaming the motor. A tech's actual first move is different. They clamp an amp meter on the power feed to the slide motor and watch the draw while it operates. A healthy slide motor under normal load draws a fairly consistent, predictable amperage through its travel. A spike partway through the cycle means something mechanical is binding at that exact point. A roller, a track, a piece of debris, not the motor itself. A steadily climbing draw across the entire cycle points toward worn brushes inside the motor. This 5-minute test tells you whether you're looking at a lubrication and alignment problem you can fix yourself in an afternoon, or an actual motor replacement. And it means you're not paying to replace a perfectly good motor, because the real issue was a dry track that needed cleaning and a specific slide-out lubricant. That naturally leads to the next point. Secret number 8. Why torque on your hitch ball matters more than the size stamped on it. Everyone checks that the ball size matches the coupler. Almost nobody checks torque, and an under-torqued hitch ball is a hidden failure point that has nothing to do with the ball's rated capacity. A hitch ball that isn't torqued to its specified value, which is typically printed on the ball's shank or in the mount's documentation, can work itself loose from the vibration of normal towing over just a few thousand miles. The threads look fine, the ball looks seated, but it's slowly backing off under the truck's own road vibration. A mechanic checks this with a torque wrench at the start of every towing season, not just at initial installation, because that torque value can decrease over time even without visible movement. Most hitch balls call for somewhere in the neighborhood of 250 to 400 foot-pounds, depending on the shank size, and retorquing takes under a minute with the right wrench. Here's where the story changes. Secret number 7. The Awning arm tension trick nobody adjusts until it fails. Manual and semi-automatic awnings hold their extended shape using spring tension built into the roller tube itself. Over years of sun exposure and repeated use, that spring tension weakens, which is why an older awning starts sagging in the middle or won't fully retract on its own anymore. Most owners assume this means a full awning replacement. What a tech actually does is access the spring tension adjustment at the idler end of the roller tube, where a series of holes lets you retension the spring by rotating the tube and repinning it at a tighter setting, adding rotations in small increments and testing extension and retraction between each adjustment. This is the exact same mechanism that came preset at the factory. It just needs periodic retensioning the same way you'd adjust a garage door spring, and it turns what looks like end-of-life awning failure into a 10-minute fix. The next one lives inside a system most people only think about once a year, right before it fails on them. Now consider another example. Secret number 6. Why fridge cooling units get a boiler tube tap test before anyone condemns the whole unit. An absorption refrigerator that stopped cooling gets blamed on the cooling unit itself almost automatically, and a full cooling unit replacement is one of the most expensive single repairs on an RV. Before going there, a mechanic checks for ammonia crystallization by lightly tapping along the boiler tube section at the back of the unit, listening and feeling for a distinct rattling or grinding sensation that indicates the ammonia solution inside has crystallized rather than flowing freely. This has to be done while the unit has been off and level for several hours first. A cooling unit with early stage crystallization can sometimes be brought back by running it in an unusually level position on high heat for an extended period to redissolve the crystals, buying months or years of extra life. A unit with no crystallization at all, but that's still not cooling, usually points to something far cheaper, like a boiler tube leak, a bad thermistor, or an electrical heating element issue, none of which require replacing the whole cooling assembly. The next one deserves a closer look. Secret number 5. The frame flex check that predicts stress cracks before they show up in the fiberglass. Stress cracks around windows and door frames get blamed on manufacturing defects almost every time, and sometimes that's accurate, but a huge number of them are actually caused by chassis frame flex that's transmitting stress up into the body structure. The test a mechanic uses is parking the rig with one side on ramps, essentially creating an exaggerated diagonal twist across the frame, and then watching door and window gaps while a second person gently rocks the corner of the rig by hand. If gaps visibly open and close during that flex test, the frame or its mounting points are transmitting more movement into the body than the structure is designed to absorb. That usually points to worn, compressed, or deteriorated body mount bushings between the chassis frame and the coach structure itself. Those bushings are supposed to isolate some of the chassis movement from the living compartment, but as they age, they can lose their ability to absorb that motion. The result is that the fiberglass and interior structure start taking forces they were never intended to handle. Replacing the body mounts is typically a fraction of the cost of repairing extensive fiberglass damage, and more importantly, it addresses the actual source of the problem. Simply filling the cracks with sealant or cosmetic filler may make the damage disappear temporarily, but if the underlying movement remains, those cracks will eventually reopen and the repair will start all over again. That is why watching how the gaps behave during a controlled flex test can tell you far more than simply looking for cracks after the fact. You're not just checking for existing damage, you're checking whether the chassis is still transferring excessive movement into the coach. And then there is this one. Secret number 4, the holding tank valve technique that actually extends blade life. Most owners know to run tank valves periodically so they don't seize, but the actual technique matters more than the frequency. A mechanic doesn't just open and close the valve, they open it fully, let it sit fully open for several seconds, then close it fully and hold pressure against the closed position briefly before releasing. This full-range, held-position cycling seats the valve blade evenly against its seal rather than just wiping across the middle of its travel, which is what happens when someone quickly flicks a valve open and shut. Valves that only ever get partial, quick cycling can develop uneven wear grooves right where the blade repeatedly contacts the seal at that same half-open resting point. Every time the valve is opened and closed only part way, the same small section of the blade and seal takes most of the friction and pressure, while the rest of the sealing surface barely gets used. Over time, that concentrated wear can create a path for water to seep through, even when the valve appears to be closed. Eventually, you may notice a slow leak, difficulty getting the blade to seat completely, or a valve that simply doesn't feel as positive as it used to. The fix costs nothing because it is purely a matter of technique. When operating the valve, move it through its full range, rather than repeatedly stopping at the same halfway point. That distributes wear across the sealing surface instead of concentrating it in one location. It is a tiny habit, but it can add years to a component that is relatively inexpensive to operate, yet surprisingly unpleasant to replace once it starts leaking or becomes difficult to access. Now things start to change. Secret number 3. Why a mechanic tests city water pressure at the RV's own inlet, not at the spigot. Campground water pressure varies wildly, and a lot of internal plumbing damage that gets blamed on manufacturing defects is actually pressure damage that built up slowly over multiple seasons at high-pressure parks. A pressure regulator at the hose inlet only tells you what's coming out the other side of the regulator. It doesn't tell you if the regulator itself is failing internally, which they do over time. The trick is threading a simple inline pressure gauge, the kind that costs under $15, directly onto the RV's own city water inlet after the regulator, and checking it periodically rather than assuming the regulator is doing its job forever. A properly functioning regulator should hold output somewhere around 40 to 50 pounds per square inch, regardless of what's coming in from the spigot. If you're reading meaningfully higher than that at the RV's own inlet, the regulator has failed internally, and every fitting, valve, and connection downstream is being stressed every time you hook up to water, which is exactly how slow pinhole leaks develop behind walls where nobody sees them until there's already damage. Now watch what happens next. Secret number 2. The wheel bearing sound test that catches a failure weeks before it strands you. Bearing failure on a trailer axle doesn't happen suddenly. It builds for weeks, and the early warning sign is audible if you know what to listen for and how to check for it. With the trailer jacked and the wheel off the ground, a mechanic spins the wheel by hand and listens closely, feeling for any grinding, notchy resistance or roughness as it rotates, rather than a smooth, quiet spin down. They'll also grab the tire at the 12 and 6 o'clock positions and try to rock it top to bottom, feeling for any play, which indicates a bearing that's already lost preload. This 2-minute check, done at the start of every trip, catches bearing wear at the stage where a simple repack and adjustment fixes it, instead of the stage where the bearing has already started breaking apart and can take out the spindle or cause a wheel separation at highway speed. Most roadside bearing failures were audible or feelable for weeks before they happened. They just never got checked. And now, the number 1 secret. The one that experienced techs know saves more RVs from serious damage than almost anything else on this list, and yet almost nobody outside a service bay has ever heard of it. Next on the list is a name you might recognize. Secret number 1. The converter output voltage test that's quietly killing house batteries across the entire industry. Every RV's converter or charger is supposed to deliver a specific voltage to keep your house batteries charged without overcharging them. And that voltage target is different depending on whether you're running flooded lead acid, AGM, or lithium batteries. The trick almost no owner performs, and a shocking number of techs skip too, is actually testing the converter's real output voltage at the battery terminals themselves with a multimeter, rather than trusting the converter's rated specification on its label. Converters drift out of calibration over years of use, and a huge percentage of them are quietly running 1 to 2 volts higher than they should be, cooking batteries slowly through chronic overcharging that shows up as swollen battery cases, rapid water loss in flooded batteries, or a lithium batteries management system throwing constant high voltage faults. The test takes 5 minutes. Fully charge the batteries, let the converter settle into its float stage, and read voltage directly at the battery posts, not at the converter itself, since voltage drop across wiring can mask a problem or hide one. If that reading doesn't match what your specific battery chemistry calls for, the converter needs either a settings adjustment, if it has selectable charge profiles, or replacement with one that matches your battery type. This single check is responsible for more prevented battery deaths than every other maintenance habit on this list combined, and it's the one thing almost every RV owner has never once thought to do. If this answered some questions, subscribe and stick around for more.